Hey there and welcome. Today we are diving deep into a piece of tech that is, no joke, running most of the digital world you interact with every single day. It's called virtualization, and it's basically the magic trick that lets one single computer act like an entire fleet of them. We're going to break down exactly how it works.
So let's just start with this one big question. What if you could take one powerful physical computer and somehow make it behave like dozens or even hundreds of separate little computers all running their own thing at the same time? I know, it sounds a little out there, but that is the exact problem that virtualization was born to solve.
And to really get our heads around this, we have to start with the fundamental building block of this whole world. We're talking about the concept of a digital twin for a computer.
And that digital twin has a name, a virtual machine, or just a VM for short. Put simply, a VM is an entire computer system. We're talking operating system, applications, everything that exists completely as software. You can't touch it. It's a guest that lives inside a physical host computer, borrowing a slice of its CPU power, its memory, and its storage.
Here's a really great way to picture it. Imagine a huge empty office building. That's your physical server. Now virtualization comes in and starts putting up walls, installing doors, and running electrical, creating all these individual, totally separate office spaces inside. And here's the kicker. If you're inside one of those offices, one of those virtual machines, you have absolutely no idea the other offices even exist. You're in your own little world.
So why would we even go through all this trouble? Well, it turns out that creating these digital twins unlocks some really serious superpowers when it comes to managing technology. And this is where it gets really good. I mean, think about it. Instead of having a server that's just using maybe 10% of its power to run one single app, virtualization lets you carve up that server and use nearly all of its power to run many different things. And security gets a huge boost. If one of those virtual machines gets a virus, who cares? It's trapped in its own little sandbox. It can't spread to the others on the same hardware. And of course, the big one, cost. You're buying way less hardware, your electricity bill goes down, and you don't need a massive room for all your servers. It's just a massive, massive win.
And don't think for a second this is some niche, nerdy tech. Over 90% of businesses are using server virtualization today. It's not the exception anymore, it is the absolute standard for how you build and run a modern data center.
So how does this trick actually work? What's the secret sauce that makes it all possible? Okay, let's peel back one more layer and look at the engine that drives this whole thing.
The secret ingredient is a special piece of software called a hypervisor. Honestly, the best way to think of it is as the traffic cop for the physical computer. It's this thin layer of software that sits right on top of the actual hardware, and its job is to create and manage all the virtual machines. It decides who gets how much CPU power, who gets how much memory, and just generally makes sure that everyone plays nicely together and doesn't step on each other's toes.
So, when you put it all together, the difference between the old way of doing things and the new way is just, well, it's night and day. In the old world, you had one server for one job. It was expensive, it was slow to get a new one up and running, and most of the time the hardware was just sitting there bored. With virtualization, one server becomes this flexible, super efficient powerhouse that can do the work of dozens of those old machines.
And this slide right here, this says it all. Look at the left. That's the old way. A whole rack of separate physical servers, one for each application. Now look at the right. That's the virtualized world. All of those jobs are now just virtual machines, all humming along happily on one single powerful host server. You're getting the same amount of work done with way less hardware.
Okay, so this all sounds great in theory, but where does this stuff actually show up in our lives? The funny thing is, you have almost certainly used virtualization today, probably multiple times, and you didn't even know it.
The biggest one, by far, is the cloud. Amazon Web Services, Microsoft Azure, Google Cloud, that is virtualization. When you spin up a new server in the cloud, you're not getting a physical box. You're getting a VM. It's also absolutely essential for software developers who need those safe, isolated sandboxes to test their code without breaking anything. And it's a lifesaver for big companies that have ancient but critical software that they need to keep running on modern computers.
And this doesn't just stop at one server. This technology is what allows us to build entire data centers. Now this diagram looks complex, but the idea is simple. You take big clusters of physical servers, massive shared storage systems, and all the networking, and you virtualize the whole shebang. It all becomes one giant, flexible pool of computing resources. And from that pool, you can create thousands of virtual machines on demand. This right here, this is the blueprint for how the modern cloud actually works.
But look, like any really powerful technology, it's not all sunshine and rainbows.
virtualization has its own set of challenges, and it's important we look at those too.
For one thing, while it saves a ton of money in the long run, getting started can be pretty expensive. You need really powerful host servers to run all those VMs, and managing this kind of environment requires some serious expertise. Plus, there's a big risk. If you put all your eggs in one basket and that one physical server fails, you could lose dozens of virtual ones all at once. That's why building in backups and redundancy is just absolutely critical.
So I'll leave you with this final thought. Virtualization completely changed our relationship with computers. It took the idea of a rigid, physical box and turned it into a fluid, flexible resource defined entirely by software. As this trend just keeps accelerating, blurring the line between hardware and software even more, you have to ask yourself, what will the computer of tomorrow even look like? Thanks for tuning in to see how this all works.